Trying to minimize. I forgot how I do it every time. Right. I can see myself then, but it's fine. All right. Welcome. There we go. Okay. All right, there we go. Welcome to, sorry about that. Welcome to week 7 of the school year. This is severe weather meeting number 4. I don't know, I can't keep track anymore, but today I'm just gonna go over the weather that's gonna go on now. And I'm gonna talk about, I'm finally getting the annual fundraiser going, and we'll talk about that. And then Dr. Finch is gonna do weird weather, and like you can ask some questions about it, right? Yeah. Yeah, so what's the state? Okay, I think so right now there's a low pressure out to the west that is bringing in rain, but it mostly is to the south right now. But when the cold front passes, it will be, there are a chance of storms, isolated storms tonight around 10 o'clock. This one.
Silent.
Yeah, I was gonna.
Start this just and then go.
Yeah, start. That's what it was.
You know, if you just read DVD and AFD, you know, USB and AFD, you probably.
Okay. So the discussion, as you can see, water vapor imagery. You said Nessus star, right?
Star, that's just. And then goes.
Here. Where is it at? I had it up on my computer.
Yeah, water vapor.
Mid-level? Hmm?
Mid-level.
Yeah, that's what I was doing. Hey, I clicked on the wrong thing. Great.
Goes east, then comes.
All right. Now you can see it out here. This is, you can see the low pressure spinning out here. Basically, it's gonna, for tonight, this is going to, the cold front is gonna come through, but it's not gonna be super strong, but it will produce some isolated storms because the mid-level lapse rates and most unstable cape will be high enough to create some possibility for hail, but who knows, but
So a note for the new students last year is how fast the year rules will.
Yeah.
Okay, and when you talk about Kate, let's see the amount of available energy for the thunderstorms. Typically, when we think about Kate, we think about lifting from the surface. But for these storms, you're not gonna be lifting from the surface. You're gonna be lifting from somewhere in the middle atmosphere, and the thing that's doing the lifting is the cold front.
And then, fog is possible, and I had it up. Fog is possible tonight, taking too slow. As you can see right here, you're looking around, 4 to 5 a.m. because the dew point and the temperature are pretty close together. And so that's probably what you would see around the time you see patchy fog that could occur. It says for tomorrow, there is a big cold front coming, of course. For the weekend, it's supposed to be Friday, and to the weekend, it's supposed to be high of the 50s. But for tomorrow, the cold front is going to be reaching like northern Illinois, and it will produce non-diurnal temps, which will means it will be warmer in the morning and then colder during the day because of the cold front that's coming through. Yeah, and for us, it'll be in the 70s because we're south of the Quad Cities. With the cold front, it's just mostly just talking about the north for tomorrow because that's what we're hitting. As you can see, it's very dry out. We're not going to get much higher dew points at all. So I don't think anything is going to be too extreme if it does happen. But the cold front this one will be stronger that's pushing through. Yeah, this is mostly just talking about the north for tomorrow. And then Friday, there's high pressure that will build in, and this will be very cold with the upper 50s, cold, or in my opinion, and lows. It doesn't say the lows, but I think lows are gonna be in the 30s, which are not very good in my opinion. And then the storms that do occur, back to tonight, the storms that do occur tonight won't create much rain at all, 1/10 of an inch possible. It's the surface boundary is pretty weak, so not much is gonna happen.
It's sort of very dry.
It is, that's the big thing, it is dry out.
We've got precipitation.
Yeah.
Atmosphere.
Yeah, the storms are very high base, so like the rain will fall, but it won't reach the ground. Because you can look outside right now, the clouds are pretty high up there, and yeah, it's gonna stay like that because if they were lower, it'd be pretty humid out.
Scroll down there a little bit. Right there, what's on the FLRPA?
It's the frontal passing.
That's on the.
Yeah. That's pretty much it for our weather. Yeah, I do too.
See where it's dry. And
So on to our candle fundraiser. I have the forms up here, so where do you grab one? I ordered 25. So you said that there's gonna be some people out of the bother myself. Yeah, sorry. Right.
We should also put one in the department office and I'll send it to everybody, let them know it's there,
Okay.
right?
And I have the website up. It's actually very simple. I thought it would be like way harder than this, but they already set it up for me. So when you guys put out this is what you're gonna put out for on your Facebooks or whatever. You're gonna put that right there, the iRacingMore.com, and group ID is 45055. So make sure people put that in, and then it will show you the store, and then I have access to the funds that we'll be getting. This isn't one I'm gonna have. It's not gonna be much. You just have to check it every so often. I'm gonna have you check it, you're the one running it. So it's, yeah, all you can do is check it like a few times, like 1 time a week maybe, and see how it's going. So yeah. I'll show you the store actually.
What's the deadline?
It's a good question. Hopefully we should discuss.
Yeah. Yeah, we probably should discuss that. We didn't discuss it like.
Because- Yeah, they come. Never come.
Sports and cleats.
Yeah, of course, this week though, we gotta have to on. I just give them all Brandon Reynolds and all, so.
Yeah. and the red- everyone else is like, yes. Absolutely. You might tentatively say a deadline in like 2 or 3 weeks.
Yeah.
And reach out to the company and find out.
Yeah, I think it is, yeah, 3 weeks, that's what I remember seeing, I can't find it right.
Well, no, I mean for us to sell,
Yeah.
but and reach out to the company and see how long it's gonna take them to deliver.
Yeah, I can't find, I'll look at it after it, later. But, yeah, this is basically it. It says you are supporting Western Illinois Severe Weather Club. And people can just add it to their cart and buy it. You have to let people know if they're using this, there is a 95 cent charge for using a credit card on this. So that's just a small thing you have to let everyone know. Yeah, this is pretty much it.
And they don't ship them out, is that true?
Hmm?
The people who order put in their address and they pay for shipping.
No, it actually, every cat comes here and that's when we distribute it. So, yeah.
Is that what, yeah, okay.
Yeah, so that's what it said, you can't really go out of state with it, so it has to be people like close to you, like if they just want to go on here and do it. Yeah, they don't give it out to people away, unfortunately.
Business thing.
Yeah,
That would be-
yeah, so I didn't, yeah, I should. Yeah, I think that's pretty much it. For this. Yeah. I'm with
Okay. All right, so last year I did a strange weather event, there's a lot of pictures and things like that. So this year, what I want to do videos. So there are a couple of clips of videos that I want to look at. For this first one. Yeah, we'll get to that. This one. Okay. And we don't need volume, so the volume is down. Again? Wait, this was only 13 seconds though. So. Okay. So we know what rain is, rainstorms, things like that. What's shown here in just a second though, is that. And none of the other cars are getting rained on. Oh, right.
That was terrible.
Yeah, pretty good, it's a nice little.
Now. My question for you is, do you believe it?
Yeah.
I don't know.
I have seen something like this, right? I remember in Georgia when I was a kid, it was raining in the front yard, not in the backyard. Okay, stuff like that happens all the time. Okay? My concern here is how hard it's raining. And if the atmosphere were moist enough to support that hard to drop, chances are it'd be raining in more than one place. Okay? The other thing that I found strange, this video goes on for a couple of minutes. The other thing I found strange is that it moves a little bit, not a whole lot, and not in a consistent direction. Which makes me think something got right. You saw him just a minute ago look up, right? And you can see the raindrops. So somebody's behind him with a hose, looking back at the same. So I have seen something like this, but I'm a little skeptical if this one's true, right? Just because those raindrops are so big, like you said, somebody can drown, right? But if the rain was hitting this car so hard, there would be rain in other places as well, right? So when you come up with these videos like strange weather, things like that, which I love, yeah, you have to be a little bit careful. So it shows all the other cars, they're completely dry. Shows up again. I'd be more convinced if you went right there and like really looked up and looked around. Yeah, so look, it's amazing. Yeah, it's where the garden house. So, yeah. And you see it kind of moving like this a little bit. If it was natural precipitation, it would be moving like that. Right? So I saw this and I was like, oh, that's cool. Fake, but cool. Right? Yeah. So that one I don't believe. There are several that I have that I do believe. Let's see, what else do we have on here? So this one is water spouts. And the beginning of a water spout. Come on, let's get back to water spouts. Now, this one is actually pretty interesting. Because while it is happening over water, and you can technically call them water spouts, they're actually not. Here they call them water spouts. They're called land spouts. And what happens is what you need in the atmosphere is you need a convergence zone. This often happens in the middle of valleys. Maybe got the air coming down on both sides of the pools. You need a convergence zone to lift up to form some clouds, but you also need wind shear. And that wind shear is going to spin up these little tornadoes. So while this is over water, it's actually a land spout. And I've seen as many as 8 of these in a row. So yeah, pretty cool. On a day when it's not raining, not a whole lot as far as clouds go. But what's causing this is wind shear, horizontal wind shear is spinning up little vortices. Yeah. So I thought this one was pretty cool. They call it a water spout, but it's really not. The dynamics here are land spout, not water spout. Anybody seen a water spout? It's clear. It's like it does have a little bit of water. This one's not clear. So it's definitely a land spout over the water. Pretty cool though, right? I mean, can you imagine looking out there at all those tornadoes? That'd be amazing. All right, what else do we have? Tornadoes, I won't spend much time on this. One is cyclonic, one is anticyclonic. So you've got the rotation heading this way. It's pretty rare. Why? Yeah, typically you have an updraft in the mesocyclone. The mesocyclone itself is like a ring that's rotating, okay? You need instability to come up a couple places on that ring. The reason it doesn't happen all that often is if you think about a thunderstorm. So I'm going to draw a plan view, hook echo, right? Your tornado, this part right here. This part is the part that's rotating. Okay, so that direction is north. And I'm looking down, okay, bird's eye view. What I've got here is I have typically inflow, okay? And in order to get two of these tornadoes, let's say one here and one here, one is gonna be in a drier environment. And so often you won't get them. Okay, just because of the environment all the way around the storm. One of these is gonna be in an unfavorable environment. To have them this close probably means one created the other. If they're pretty far apart, they get created independently. Okay.
Do you mean like when they're close together, they can do like one right to the other from its vortice?
Yes. So the vortex of one created the vortex of the other. So one of these is typically much stronger than the other. That one's a little bit smaller, that one's a little bit bigger. So one's the driver, and the other is sort of following along. Here's a great example. So this one created that one. And if you've got really strong, you know, you have 4, you have 5 tornadoes, that's a possibility. The other possibility is instead of it creating its own sibling, it creates something called suction vortices. Here might be some examples, little swirls that rotate around the tornado. Anybody heard stories of one house that was gone and the neighbor's house is untouched? Suction vortex. Teeny tiny tornado that rotates around the bigger tornado. All right, what else do I have in this one? We saw that one. Those are, so these little fire tornadoes. That's right and heat. You've got plenty of rising air, so all you need is something to cause it to rotate. I think that's it for that one. All right, let's see what we have here. That. Gorgeous. These are called ice flowers. Beautiful. Look how delicate they are. What happens, we have moisture in the stem of whatever plant they're coming out of. As the temperature drops, the moisture extends and it grows these funky shapes. See how fast it's melting? You need pretty calm conditions. You need right at the surface to be very, very cold. So clear skies, calm conditions typically. It can't have frozen much before this. Otherwise, this would have already happened.
So it would be like early in the morning.
It would be early in the morning when you would see them. They're growing throughout the course of the night as the temperature drops. Gorgeous. I love crosstalks.
So will this happen more like in the transitional period from summer to winter?
You would definitely have to get an early frost. I would say the temperature would have to be below freezing, not just right as the sun comes up, but throughout a good portion of the night. So not now, probably in November, right? But that's how it's growing. And then the same thing happens on the tops of lakes and things like that. Okay. All right, so we've got cloud iridescence, which is cool. Snow rolls. Have anybody seen those? Yeah. Pretty cool. What are they for? I mean, you get a little snowball that starts, right? Where are the rolls? Sometimes. Those, yes. But I mean, I've seen the fields around here. They're flat. Yeah. Yeah, sometimes wind will do that. Yeah. Pretty cool though. They do happen more often when you have slopes, but like I said, I've seen small ones around here. If we have like really screaming wind and a good kind of snow on the ground. And it's the right kind of snow, because if it's light and fluffy, it's not going to stick together. Okay, but if it's a thicker, warmer snow, you're gonna get stuff like this. Yeah. All right, what else we got? This is always cool. Volcanic lightning. There was an eruption up in Alaska probably 5 years ago. And scientists all rushed up there to study this because we had no idea what happened. Okay, and this was 5 years ago. They published some papers, it's all friction. Like literally all friction. Drag your feet on the carpet, touch the doorknob, you get zapped. I'm familiar. Right? All friction. Yeah, you build up static electricity in the soot because it rubs against each other. Very cool.
What eruptions are then more common?
I would guess they're more common with the ones that are,
Like that happens all comes.
yeah, I mean, if you go to like Hawaii, okay, and you have an eruption there, and there's fissures all over the ground, and you have little eruption, little eruption, little eruption, I wouldn't expect them to occur there. I think you almost have to have something that is big and high to get it.
Can also be like how, you're
Could be, but I would say that's a lesser thing, just because it's so hot. Right. Yeah, you're gonna have moisture, and moisture is actually what causes it to be explosive. I'd say that if you have really big chunks, you're not gonna get much in the way of lightning. But yeah, the more dust and debris and stuff like that you send up, that's like plume. Yeah, the more likely you're gonna have lightning. Now, this is pretty cool. They call these glory clouds, they're roll clouds. So here. Basically a line of clouds, and if you watch carefully on some of these. Not so much on this one, sometimes they're rotating, and I mean really rotating. You can see that rotation very clearly. I don't know if it's this video or if it's another one that I have, but you can see the rotation. These are mostly still shots. Now, one way that we get roll clouds is if you have a big thunderstorm. Yeah, I think these are mostly stills. Okay, so one way that you can do this, if you have a big thunderstorm, let's say I've got the ground down here. I'm gonna draw my supercell. Okay. I would have a wall cloud, a tornado, if we've got a tornado. Here, I've got the updraft, and here the rain is falling down, causing a downdraft. And anybody ever been around a thunderstorm as it's just getting going? You get that whoosh of cold air, right? That's the gust front. So my gust front is somewhere around in here. And I've got another updraft in here because of that gust front, and I get rotation. Okay, so that's a nice road cloud. Let's see. What's that?
I gotta find the spooky earrings.
I know. That's why I kind of ignore the volume, right? Oh, raining fish. It is a thing. In Georgia, we had it raining minnows. Little ones. All right, what else do I have?
Speaking of like raining animals, I have this like book that's like on weather,
Uh-huh.
and one of the sections it's about the frozen frogs. The tornado went through and sucked them all up and threw them somewhere else, and then they frozen somewhere.
Right. Oh my gosh. Oh, yeah. All right, what do we have here?
that. That's a fog tsunami. So it's like a fog bank that rolls in, then it's something and it goes over on top of that something.
Tornadic water spout. This is a tornado that doesn't occur on land, but on water.
Tornadic water spouts. Never heard that before.
And arises as a
Okay, I think this is the one with the actual animation.
cloud that is several hundred kilometers long, but only 1 or 2 kilometers wide. Above the cloud, there are strong updrafts,
Yeah,
and behind it, the earth is
It's irrelevant.
turbulent.
Wow, right?
Up to 60
That was caused by wind shear. This one is also wind shear, but it's wind shear created by a thunderstorm. And then these are basically big ice crystals.
by the unbidden melting of snow and ice.
and the commercial. All right.
The bottoms of these
And so what you need here is you need, so it looks like they're growing from the ground, but it's actually a snowpack that's being eroded away by the wind or by the sunlight. Maybe there are patches that are slightly darker. That's what's going on there. Anybody seen something like this? Anybody live by the Mississippi River?
I've seen this exact video on TV.
Have you? Nice. Yeah. There are two reasons that this can happen. One, if you're on the lake, you've got the wind blowing the ice on shore. If you're on the Mississippi River, if you go driving along the Mississippi in January, February, you're gonna see lots of piles. There's a reason why people don't build right in the, near the main channel of the Mississippi, because you get ice jams, they break. The river itself is what's pushing the ice on shore instead of the wind. So, yeah, very destructive. Once this ice is coming, there's nothing you can do. Get out, you know, but that's about it. All right, what else do I have? Lenticular clouds. We don't get those much around here. Occasionally, I will see the Pileus clouds on the top of thunderstorms. But what's happening here is the air is going up and down the other side, and so you get these lenticular clouds on either side. So I want to look at that. This is actually a bit different. What's happening here is the sun is shining on the mountain, warming the air slightly, the air is rising. As the air rises, it creates these clouds. Okay. My guess is that once a cloud gets. What do you? Once a cloud gets high enough, it allows more of the mountain to be exposed. There we go. That. Okay, it allows more of the mountain to be exposed, which allows it to warm, which allows it to form another layer. Okay, so that's probably how you get those layers. We see something similar to this along, if you look at the tops of thunderstorms, you get these little lenticular, they're called Pileus clouds at the top of thunderstorms. So we see those around here pretty often. What else? More ice flowers. Bleeding snow.
Mineral deposits.
What's that? They are mineral deposits. Things actually bleeding, right? It's coming from the ground. What mineral tends to make red? Iron. Yeah. That way, when the earth was forming, how we got the oxygen, you basically, initially we had no oxygen, and then anaerobic bacteria that could not be around oxygen in swamps, created oxygen, but the first thing that it did was not live in the atmosphere. The first thing that it did was oxidize everything. Anybody been to Georgia? The dirt is red, like red. And that's a remnant of that oxidization phase when the earth first formed, which is pretty cool. We still have anaerobic bacteria. If you've ever been around when they dug up a swamp, that black sludgy gross, that's anaerobic bacteria. Yeah. It's pretty nasty. All right, I think that is about all I have. Yeah, so I hope that's fun. Like I said, I really like the strange weather. My severe weather class is severe and unusual weather. And so, yeah, I mean, the cooler the better, right? Mother Nature, whew, she's amazing. Questions, anything? All right, that's all I got. Good, if you want to take it over.
Thank you, Dr. That's pretty much gonna wrap up. I do want to mention that next week, you guys should come because, Nick Stewart is gonna be here presenting. Yeah, and he's gonna bring the storm chaser that he uses, on, the news that he works in. So he wants to show us it, so I would not miss next meeting. Yeah. And I will put out the website and the code on Discord, so everyone can do it. Yeah. That's pretty much it.
Nice. Thank you.
Thank you for doing that. I appreciate it.
If you guys find strange weather, it's the key.